So the question for today is a bearing question. The diagram you find here has 3 points A, B, C, but all of them are on the same horizontal ground. A, B, and C are on the same horizontal ground. Point B is 15 meters from point A. Point B is 15 meters. Can you see? 15 meters from point A on a bearing of 53 degrees. On a bearing of 53 degrees. Can you see that? Point C is 18 meters from point B. Can you see point C? It's 18 meters from point B on a bearing of 161 degree. On a bearing of 161 degree, as you can see. A vertical pole with top T is erected at B such that angle ATB is 58 degrees. See here, this is the vertical pole BT. So as you can see, the angle you find at ATB is 58 degree. Alright. Calculate, correct your 3 significant figures: the length AC, the bearing of C from A, and the height of the pole BT. These are the tasks that we have to complete in the exercise we have right on screen. So we are going to begin immediately by solving the problems. Now, let's get the party started. Since length AC is our very first focus, we'll begin this way. Solution. So we start with A. To find the value or the dimension of length AC, we'll go back to the diagram and identify where AC is. This is point A, this is point C. This is not a right angled triangle, so sine rule or cosine rule will obviously apply. But let's see what we're going to work out. For us to find AC, we will need angle at B. So the first thing we are going to do is to analyze this angle at B to know what it is. So let's do it right away. This is a straight line running from north down. This is east, west, north, and south. So it runs from north to south. This is S, okay? If this straight line, we already have the bearing of C from B as 161, what will be left to make it 180? Since angles in a straight line is 180. We just have to subtract 161 from 180, and that is going to give us 19 degrees. So this part, we can call it angle CBS as 19 degrees. Now to complete the angle at B, we're looking at this part. Now how do we know what this part measures? They already told us that the measurement of TB, the pole at TB, the measurement is not given, but the angle ABT is 90 degrees. Now we're looking at finding the angle at this point, maybe finding this again will also help us, because the angle TBN added to the angle ABT and added to the angle ABS, all of them all together will equal 180. So take note of that. Let's see how we can find the missing angle at this spot. Now take a look at this. This is N, the north, and this is N, the north. This line heading to north and this line heading to north are parallel lines. So what it means is that the angle 53 is alternate. I mean the angle TAB. Let's write it down here. Notice from this that the angle TAB is equal to the angle at CBA minus 19, or you can say angle ABS. So the angle at TAB is the same thing as angle as ABS. It's the same thing as angle at ABS. The reason for this is because both of them are alternate angles, and we know that alternate angles are equal. Remember that. So we can conveniently say that the angle at ABS, which is this angle missing here, measures 53 as well. We'll write it down like this, 53 degrees. Alright, since we've been able to find this angle 53 and this angle 19, it means that the angle at B altogether will measure 53 add 19. So what we know is that 52 add 20 will give us 72. So 53 add 19 is the same thing as angle 72 degree. Alright, now that we have found what this angle measures at 72 degrees, we can easily apply the cosine rule to find the missing length AC. Yes, cosine rule is going to work out well in this case since our angle is present. You get the point? So we're going to go straight ahead and find what is missing for AC. Therefore, applying cosine rule to the triangle ABC, what we know is that B squared is equal to A squared plus C squared minus 2AC cosine B. This is the cos rule that will help us since we already have the angle at B. And so to do that, let's work it out. Now, if you go back to the diagram, you will notice that our A squared is 18 meters squared. So our A squared is 18 squared plus, what's our C squared? From the diagram, our C squared is 15 squared. We write it down, 15 squared minus 2 times 8, 2 times 18 times 15 times cosine of B. Our cosine for B is 72 because we already found out that when we added 53 and 19, we ended up with 72. So it's cosine 72 degrees. Now, with the information we have so far, we come down again with our B squared to find side B. So our B squared is going to be 18 squared plus 15 squared. We can just use our calculator to make this work out easily for us. So let's punch the calculator. 18 squared add 15 squared minus 2 times 18 times 15 times cos 72 times cos 72. This is equal to 382.130823. It is always advisable to write decimal numbers as long as possible. Don't abbreviate them at the moment. Don't approximate, okay? Because approximating opens you up for the wrong answer. So since we have this already and we're looking for the value of B, we can just take the square root of both sides. So our answer will be B is equal to the square root of 382.130823. If we take the square root of this, our answer for B, which is the same thing as line AC or length AC, will be equal to the square root of this answer. Square root of the answer we have here is equal to 19.5482. 19.5482. But the question had told us in the beginning that all the calculations we should do should be corrected to 3 significant figures. Therefore, we simply say that length AC is equal to 19.5 in meters. Okay, the first answer is done. Now we're going to question B to find the bearing of C from A. See, B says find the bearing of C from A. What this implies is that we want to find how many times or how many angles the movement from the northern part of A turned before it could face C. So how we can say that is we are looking for this angle. Starting from this line, we want to see how many angles it turns to touch this line, because that is what calculating the bearing of C from A implies. So to enable us to do that, remember we already have the length AC as 19.5 meters. We already have that. So since all our sides are complete, we are only looking for this angle. Let's call this angle theta. So we are looking at angle theta right now. So all we need to do, we can apply sine rule since all our sides are complete and we have one angle in there. We can use angle B and side B, then angle A, which is missing, and side A, which we already have. So let's apply that right away, as this will help us. So we're going to use angle B and sine B to work this out. So to get theta right now, we are going to apply the sine rule thus. So it's going to be, for B, we're going to say sine A all over A is equal to sine B all over B is equal to sine C all over C. Remember that, yeah? This is the sine rule. But right now, we will be working just with sine A and sine B, since sine B is already complete from the question we have. So if we go back to our diagram, our sine A is theta. We just assumed theta for it. But the opposite is 18. So I'm going to fill it in right away. I'll just write sine A is the same thing as sine theta all over 18 is equal to, what's sine B? Our B angle is 72 degrees. So sine B will be sine 72, and the small b, which is the measurement AC, is 19.5. So I'm going to write it down also in the problem I'm solving thus. So I'm going to say sine 72 degree all over, my B is 19.5. We already found that. But it is safer not to use the approximated value. Work with the value that you haven't approximated so shortly. So I'm going to write it as 19.5482. Yes, this is going to give me the closest answer to what I'm looking for. So at the moment, we're going to find a way to make theta the subject of formula. And to do that, first I'll begin by writing sine theta as the subject of formula, which is equal to 18 multiply sine 72 degree all over 19.5482. This is what we've got so far. So what is the value of this, which we have on the right hand side? That means that sine theta will be equal to, let's punch our calculator and see what that is going to give to us. So I'll go like this: 18 multiply sine 72 divide by the 19.5482. So divide by the answer we already had before on our calculator. That leaves us with 0.8757. 0.8757. Alright, sine theta is equal to 0.8757, but we're looking for the value of theta. So what it means is that we're taking the sine inverse of the answer we have currently. So we'll come down here and say theta is equal to the sine inverse of our answer, which is 0.8757. So if I go to my calculator right now and take the sine inverse of 0.8757, that is going to be sine inverse of this answer gives me 61.1321. Let's leave it at that. So it means that my theta is equal to 61.1321 degree. But remember, our question told us that all the calculation we are going to do should be corrected to 3 significant figures. What this implies is that the bearing of C from A now is going to include 53 first, added to the answer we just found. Remember, it moves from this line. We already have 53 degree given to us from the question. Yeah? So we are all going to add theta to that 53 to get our final answer. So I'm going to come down here and make a short sentence on this side. Are you watching? So we simply say that for that purpose, the bearing of C from A, we'll then write down our answer. We'll show the calculation, okay? Since we've already shown our working, I'll just say, hence, the bearing of C from A, which the question wants us to do, is equal to, now we'll go back to the question and borrow 53 degree that we already have. 53 degree, add theta. And right now, from the calculation we have done, our theta is 61.1321. Remember that. So what it means is 53 degree added to the value of theta is 61.1321 degree or so. So let's add this together and see what that gives us. Add 53 to what we already have. That is 114.132 etc. So we leave it at 114.132 degree. But see, we must follow the instruction of the question. Correct your answer to 3 significant figures. Therefore, our final answer will be 114 degree, because this is the 3 significant figure you can derive from that. Now we have successfully solved the second question also, that wanted us to find the bearing of C from A. The answer is 114 degree. We have one more question to deal with, and the question is the height of pole BT. Remember that when we were given the question to solve, we were told that a pole BT is attached on B, such that the angle at ATB, you can see the angle at ATB is 58 degree, which is this. So what we want to find now is the height of this pole. Now for you to be able to solve this, it's also easy. Take note of something. Look at an angle indicated here. This is a right angled triangle, which means that in a way, maybe Pythagoras theorem can work something out to find the height, or maybe we can apply rules related to right angled triangle to deal with it. So let's see what we can do to find the height of pole BT. So I'm going to write it out here. For C, to find pole BT, to find the height of BT, what we can do, now go back to the diagram to see something. We already have the length of line AB, which was given to us in the question as 15 meters. We also already have angle of 58, which is complete. So for us to know what is missing at this point, now this is what we are going to do. Remember something that we already did before. This is 53, this is 90, 53 add 90 plus something, a little number here is missing to give us 180. Don't forget that as well. So how do we find this? Now notice something we can do. The opposite of 58 is 15 meters, but TB stands in the place of the adjacent. And remember in your trigonometric ratio, which I already made a video on, I told you something called SOHCAHTOA. Do you remember SOHCAHTOA? SOHCAHTOA. In case you have not seen my video on trigonometric ratios and you have not known something about SOHCAHTOA, I encourage you to go back and learn what SOHCAHTOA is from my previous videos. I made 4 different videos on this topic, SOHCAHTOA, so that you will be able to know what SOHCAHTOA stands for, because I'm going to apply the rule right away. So from angle ATB, from triangle ATB, I am going to apply SOHCAHTOA, and TOA, which you see here, means tan. So I'm going to say the tan of 58 degree, tan is standing at T now. The tan of 58 degree, remember tan is opposite all over adjacent. The opposite of 58 degree is 15, and the adjacent is TB. And TB is what we are looking for. So the tan of 58 degree is equal to 15 meters divided by TB, or you can call it BT, whichever one, TB or BT. And remember, the question wants us to find the pole BT. So we can easily make BT our subject of formula and get what we are looking for. And yes, we can do that. Working out the subject of formula for BT, you will notice that BT is the same thing as 15 meters divided by the tan of 58 degrees. Alright, we can solve this out using our calculator. So let's see what the calculator gives us. We punch 15 divided by the tan of 58. 15 divided by the tan of 58 gives us 9.373. Let's write that down. 9.373. This is in meters. Now, it simply means, therefore, that the height of pole BT is equal to, we'll leave it at 3 significant figures as the question told us. So to leave it at 3 significant figures, we take the first 3 significant figures, 9.37 meters. This becomes the height of pole BT. We have just ended up solving all the problems that were given initially. First, we tried solving the length AC, and for the length AC, we arrived at 19.5. Second thing we did was to solve the bearing of C from A, and when we solved the bearing of C from A, we arrived at 114 degrees. And the third thing that we have succeeded doing is to solve for the height of pole BT. And right now, we have noticed using trigonometric ratios that the height of pole BT is 9.37 meters. This is how this problem is solved. Please drop your comment. Let's see what you think about these methods. And if you enjoyed watching our video, please give us a thumbs up, a like, and don't forget to subscribe. Thanks for watching.